Well, I'm going to answer that last question first. I definitely think I'm going to use it next year. The course is changing next year with the standards alignment, but there's enough of what we are doing next year in here, so I'm definitely going to use it again next year, and just going to try and go through some of the reasons, I guess, why I'm going to use it next year. Some of the highlights I kind of want to show you then are some of these. I'll get rid of me as one of the things that I'd had feedback prior to this course from other teachers and from other students as well. I'd asked the kids for some feedback, and I'd asked other staff for feedback. Kids' feedback came on the as a questionnaire, and staff feedback I just chatted to. And one of the bits of feedback was that it was a really cluttered course and it was difficult to follow, and that was the kids were finding it difficult to find what goes next. And so I spent a bit of time trying to tidy this this course up. And if I just make it look like a student, just trying to simplify this structure. It's still fairly bland and static, but every topic has got a link to the NCA past papers. Then I've put a link to the study it tips, and a chance for the kids to discuss on a forum. And then the big thing that this other teacher helped with was using books. And so all the information really is within this book, Metal and Metal Reaction Notes. There are some assignments down the bottom to do. There are some links to some practice exam papers as well. But really everything that they need was in this Metal and Metal Reactions book. And we've already seen the SLOs, which is kind of the first contents page. And then down the left here is all the rest of the content. And I copied this other teacher's idea of really making sure that the kids do work. When you stick them in front of a computer, they tend to not do work. That they walk into the computer room, and when you say, "Can you write this down?" they say, "Oh, do I have to have a pen? I didn't realise I have to pen. I thought we were working on computers. I didn't think we were going to do any work today," which is a typical reaction from them. And so one of the things that this other teacher said is you tell them to write their stuff down in their books, or copy and paste it and print it out and stick it into their books. Either's fine, but they actually have to have something at the end of the lesson in their books. And so you can see here for the first SLO, what are the physical properties? There's a task, define these terms. Task 2, find out the name, symbol and atomic number of them. Task 3, do this assignment. And so setting down an actual list of tasks for them to do seemed to help them go through those. Okay, so one of the things within these tasks is this assignment, and I played around with this in a previous topic, in an electricity topic, is giving the kids assignments to do and making that as the main bit of work. But I found quite a few issues with them not getting on with doing stuff and not actually being able to upload it, or using the computers as an excuse as to why they haven't done their homework. I tried it with this one, and this worked fairly well. It was a nice simple task. So if we click on that task, that takes you to an assignment which was on the front page, and linking from this book back to the front page I find a lot easier than telling people, then they have to go and find it and look at it. So here we've got the assignment, and the assignment is, what are the properties of the metals? Here's the instructions: create a Word document, make this table, and fill it out. And that's the entire assignment. They do that for each of the metals, and they upload the assignment at the bottom. And that was such an easy assignment that they could actually do that and complete it without very much excuse, which was quite nice. And I certainly find with assignments that you require them to do on the computers, if you make them idiot proof, then you're more likely to actually get something done as well. One other thing to highlight here, in task 2 it says find each of the above metals in the periodic table, write down its name, symbol, atomic number, group and period. I had lots of kids saying, what's a group, what's a period, don't understand, and so these are actually defined in the glossary. And so if you now click them or anywhere in the site where it says group, it will be highlighted, and if you click the word group, you've got the definition of the word group there. And that was actually completed by the students in a separate activity prior to this course going ahead. So they actually had a definition of some of the keywords, and using that glossary has been quite a cool thing to use. Some other cool things. Been trying to use some videos within the task just to make it a little bit more interesting. So this is a video about products and reactants are. Let that download while we're sitting here. Oops. There we go.
Just in time. Perfect. Another chemical reaction has just happened here.
So just trying to make those a little bit more interesting. We found that we had to download our videos and put them as FLV files rather than embedding YouTube, which got blocked halfway through the course. So this last one here won't work because it's an embedded YouTube video. One other thing I found was this thing called Woolwisher. So after looking at reactions of metals and oxygen, I wanted the students to try and add what they'd learnt to a group wall. It's a bit like putting post-its onto a wall in the classroom, but this is here for keeps. So we've got tin plus oxygen goes to tin oxide, iron plus oxygen goes to iron oxide. They just had to write down the word equations for those metal and oxygen reactions, and they could just post a sticky by clicking in there, and I think it works on here. You have to go to another site, but there's no sign in with woolwisher.com, which is just quite a nice collaborative way of putting things together. And I used that with the metals and water and the metals and acids as well. Students were losing their practical sheets, I discovered halfway through, so I played with putting the practical sheets online, found that actually the kids would far rather me go and photocopy it to them and hand it to them than to put any effort in themselves. So I gave up putting practicals on here, but it's possible to embed PDF documents within this book as well. That's just the instructions for a practical that I had to do, but it turned out to be not a particularly useful use of that bit of software. Lots of links to other websites, and something that I discovered that I do. I wanted to track what the students were doing, and whether they were, rather than just seeing if they were looking at these pages, I wanted to know whether they'd gone to these links. And so to check that they'd gone to this link, if you just link this in a book, it doesn't actually record that students have gone to it. But I came up with a sneaky way of tracking what they were doing. At the bottom of the course, on the front page, there's topic 8, which is called Links for Metals and Metal Reaction Notes. And here, I've got all the links that I'm using, and I think that one there is the one that I was just looking at. I've made this as an activity, as a link, so that any student that clicks on that, it will tell me that they've actually clicked on it. If I then, rather than linking to fet.colorado.edu in the book, if I link to this link, which is at the bottom of the screen, educo.vln /resource /whatever, if I link to that, then it will record that the students have been there. So I can then go and have a look at the various activities. I can go and see what the students have done. So if I go and have a look at reports, I can go and see how many students have looked at that cheese sandwich, all activities. Go down to the bottom, topic 8. So what students have looked at the cheese sandwich, get these logs all time, all participants, all actions, so I can see that me, Holly, and me have looked at these things since the 19th of August, which is probably about the time that I put it on. That gives me a record of who's been to look at it.
The last question probably would be, what is the implications for your school and that moving forward from what you've done? So in other words, what do you see happening longer term in your school for other subjects, other teachers and stuff like that?
Yeah, I guess one of the sad things is that although I'm sharing this with you, I haven't actually shared this with very many people in the school. I've shared it with other science teachers that were involved, but not many people are aware of it. And so I guess it's trying to kind of push yourself forward and say, hey, I've done this really cool thing. Come and see this. We've gone a little bit Moodle crazy at Darfield, and we're just at the end of the year now. The Year 9s are doing an integrated topic across 3 subjects and trying to kind of use that. And that's one thing that some of the ideas of Moodle that I've learnt has helped and been able to inform that. And certainly other teachers, the things that I've been learning, I've been able to help the other teachers that know that I know about some stuff. I've kind of been asking for tips. With this particular project, I guess it's quite a unique type of thing where you've got those practicals and theory running side by side. But I guess it would be able to be transferred to other people too. So it is worth sharing. I haven't shared it with many other staff. And I guess that would be the next thing that I need to be doing really is to be going to the boss and saying, look, I've done all this stuff. Be good to let people know about it.